We're looking at mathematical representations today. You should have done the warm-up in class, and if you did not, then you need to complete it through Canvas, okay? So what are the different mathematical models to describe the world around us? We have a bunch. So it's just basically how do we use math to represent, what do we use to represent math? We use equations, drawings, tables, and graphs. Equations are like, 2x minus 3 or x is equal to 12. So my thing is really slow. It's catching up. Okay, drawings are like visual patterns. So like if I have a sequence of numbers like 1 dot as figure 1 and then figure 2 was 3 dots. Okay, so on and so forth. A table is like an XY table. So we can, thank you, computer. Okay, so figure number is the X and then the dots are the Y. So figure 1, there was 1 dot. In figure 2, there was 3 dots, and so on and so forth. Another way to represent math is and it's also another visual way is by using graphs. And some examples are like XY plane graphs, pie charts, histograms, box plots, stem and leaf plots. You've done a bunch of graphs, honestly. Okay, sometimes we describe a situation in words, okay, as an expression. An expression is like an equation, but it only is one side of the equation. So there's no equal sign. Okay. Inequality, sometimes you can have a model that is greater than or less than and not just exactly equal to. Like I will eat as many pieces of pie that are greater than 3. So 4, 5, 6. Yeah. Okay. Another way to represent math is to use variables. So these help us to describe the unknown. Okay. Some features of mathematical models, we describe something as being continuous. And in calculus, I talk about continuous being if you can trace the entire picture without picking up your pencil. So this picture only goes from this endpoint here to this endpoint at 5 and at x equals 5. And I didn't have to pick up my pencil for that section. So that is continuous. This one is discrete. I have to pick up my pencil to place each dot. So it is basically another word to say non-continuous. Okay. An input is our independent variable. It's often time, and output is the dependent variable. So you notice that the x-axis is the independent variable, the y-axis is the dependent variable. Look at the given situation in words, and then we're going to represent those words using different representations. So our words are, a pattern starts with a single block, and then there are 3, and then there are 9, and then there are 27. So first we're going to go ahead and just draw this out. So first I have one block. I'm going to use dots for blocks, okay? First I have one block, and then I have 3, and then I have 9, and then I have 27. So what I want to do is think about what the output is. The output is the number of blocks, is what we're measuring. And the input is how do I know when there's 9 blocks or when there's 3 blocks? And I'm going to go ahead and label these the figure 1, figure 2, figure 3, and figure 4. And I'm going to leave space for a figure 0. Okay, so I know that the input, the way that I can tell how many blocks there are, is based off of what figure number we're talking about. So that is going to be our input. Okay, in a table is just another way to organize our inputs and our outputs. So I'm going to make a two-way table. The input, which is usually the X, represents the figure number. The output, which is the Y, often represents what we're measuring. So in this case, it's the number of blocks. Okay, so in figure 0, in figure 1, in figure 2, in figure 3, and in figure 4, I just look to see how many dots there are. So in figure 1, there is 1 dot. In figure 2, there are 3 dots. In 3, there are 9 and 27. If I work backwards, then I can see, let's see, it looks like I'm multiplying by 3 to get to each number. So the inverse of multiplying is to divide. So I have 1 divided by 3, 1/3. All right, that's just for fun. Next, as a graph, the information can be graphed, and this is just another visual way to see how the numbers are related to each other. Okay, so the X is the figure number, or the independent variable, and the Y is the number of blocks, which is equal to Y. Okay, so for at 1, there's 1 block. So I'm going to put a dot at 1, 1. Okay, at 2, I think we need the table. Oh, this is hard. Sorry. Okay, at 2 here, there are 3 blocks. So I'm going to go over to 1, 2, figure number 2, and then up 1, 2, 3. Okay, at 3, there are 9 blocks. So I'm going to go to 3 on the x-axis and count up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and then I can see that 27 doesn't fit on this grid, so I'm going to stop. If I were to graph my 0 at x equals 0 right here, I have 1/3 of a block, so less than 1 but more than 0. So I'm going to graph it about right there. It's even less than 1/2. Okay, and is this graph discrete or continuous? Do we have dots between each one of the x values? So do I have a dot at figure 2.5? We don't have figure 2.5. We only have figures at whole numbers. So this graph is going to be discrete. It's not connected. Cannot have decimal figures. I had to lift my pencil. Okay. Which model is most useful to you? The words, the pictures, the table, the graph? I see different things, so you can write a bunch of different things. For the table, it was really easy for me to see the pattern. So I could see the pattern was multiplying by 3 and multiplying by 3. Math is just patterns, so recognizing how the figure is growing helps me a lot. Also, the pictures also help me see how the pattern was growing. The graph, it helps me see how the pattern is growing because I can see that in between each one of these dots from here to here, there's less space than the height between these 2 dots and the height between these 2 dots. So the graph is growing like more and more and more and more as the figures are growing, as the figure numbers are growing. Okay, so up to you what you put, but go ahead and write something. Now it's time for you to start the second one. This time I gave you a picture, so I need you to write the words, the input, the output, the table, and the graph. I'm going to pause and do some writing. All right, according to the given picture, I can see that the block, what we're measuring is the number of blocks. So that's our output, the number of blocks. And the input is the figure number. I'm going to say x equals. Okay, and I went ahead and labeled those things on the other graphs. I have my number of blocks as my y and my figure number as my x. And in my table, the x is the figure number and the y is the number of blocks. So I'm going to look, we're going to start with one block. Oh, different color. Okay, we're going to start with one block. Then there are 3 blocks. You can label them on here if you want. Then there are 6 blocks. Then there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then there are 10 blocks. Okay, so let's see. Then there are 6, and then there are 10. So I'm going to go ahead and fill those into the table, just to remember a different way to represent the information. I have figure 1 has 1 block. Figure 2 has 3. Figure 3 has 6 blocks, and figure 4 has 10 blocks. Is the pattern growing the same way as our first example? No, it's a little bit different this time, and you'll explore some more of that in the next video. Okay, so we're going to go ahead and graph those. The graph's a little small, so let's go ahead and zoom. We're going to go to 1, 1. Okay, then we're going to go to 2, figure number 2, and 3 blocks. Okay, so we've grown a little bit. Figure 3 up to 6 blocks. Oh, I didn't use the up to 6 blocks, and then figure 4 up to 10 blocks. So I can see, I noticed that between each one of the figure numbers, so like from 0 to 1, 1 to 2, 2 to 3, and 3 to 4, that we are gaining more and more and more blocks. Okay, so not the same amount between every figure. Is the pattern discrete or continuous? This pattern itself is discrete because I picked up my pencil. Another way to think about it is, can you have decimal figure numbers? That's the x. Like, you have to think about, like, can I evaluate in between figure 1 and figure 2? Well, not really according to this model. Okay, so which model is most helpful for you? Definitely for me, I see the table, like the table and the graph are super helpful for me. I like to see the numbers, like, first I would kind of like to see how the numbers are related with the x and the y as values, and then I like to see the graph because it's kind of a picture of those values. Words and pictures are also important because, you know, pictures are like help our eye and our brain process information as well, like we see in graphics and stuff. Okay, and posters. That's it. I hope you enjoyed.